Okay, you gotta hear this because something huge just went down in the world of local AI. We're talking about a model so powerful it was basically set to break our home computers, and the brilliant, surprisingly simple hack that put us back in control.
You know, when a developer like Zano from Creepybits puts out a statement like this, you know the game has fundamentally changed. So what is this nuke he's talking about? Well, it all boils down to one absolutely staggering number. 64.4 gigabytes. Yeah, you heard that right. That is the file size for a single, brand new AI image model called Flux.2. To put that in perspective, that's bigger than a lot of AAA video games. It's the kind of size that makes even a really high-end graphics card just, throw its hands up and say, nope, I'm out. This isn't just a new model. It's a whole new kind of monster.
So let's get into it. Let's break down what makes this 32 billion parameter beast so different. Because this isn't just about being a bigger file. It's a completely different class of tool for image generation.
That's right, 32 billion parameters. We're not in the same league as other image models anymore. This puts Flux.2 in the same weight class as the large language models that power things like ChatGPT. It's so dense that to run it properly, you're supposed to have enterprise-grade server-level hardware. But all that size, it's not just for show. It unlocks a level of control that is just next level.
And this is the magic right here. This is the core idea that takes Flux.2 from being just another creative toy and turns it into something else entirely. It has this incredible, uncanny ability to know what parts of an image it needs to lock down and preserve, and what parts it's allowed to change.
So look at what it keeps. In some of the tests, the model kept the exact chaotic random pattern of frayed threads on a piece of clothing. It kept the specific pores on a person's skin in their exact same positions. It locks down these tiny, high-frequency, real-world details with absolute precision.
And then, on the flip side, while it's holding on to reality with one hand, with the other it surgically alters only the things you tell it to. Change the color of an object? Done. Swap one animal for another? No problem. It intelligently edits what you might call the fiction of the image without ever disturbing the facts.
And that ability, that's what makes this a game changer for professional work. I mean, think about it. If you're in visual effects, you don't want the AI to reimagine an actor's costume. You need it to stay identical while you change the sci-fi gun in their hand. Flux.2 gets that distinction. It moves AI image editing from a fun toy to a serious professional tool.
But here's the massive catch, the central conflict of this whole story. We have this amazing new tool that most of us, well, we can't actually run it. Its incredible power comes with an impossible price tag in hardware, a problem we all know as hitting the VRAM wall.
And here's why. In a typical AI workflow, let's say you generate an image, then you send it to be upscaled, then maybe to a video model. Your computer tries to load every single one of those models in your graphics card's memory, the VRAM, all at the same time. Your VRAM is effectively held hostage by the entire process, and when you try to load a monster like Flux.2 into that mix, it just crashes instantly.
And this quote, "This is the key to everything. This is the aha moment that changed the entire approach. What if we stop trying to do everything at once? What if we think about the problem in a completely different way?"
That relay race analogy is just perfect because it leads to an incredibly elegant solution. It's a brilliant shift in thinking that lets us completely sidestep the hardware problem.
This comparison says it all, really. The standard way of doing things is a marathon, where you have to carry every single tool you'll ever need in a huge, heavy backpack right from the starting line. Of course you're going to collapse. The chained workflow, though, is a relay race. The first runner, your image generator, runs its lap, passes the baton, and it's done. Its memory gets totally cleared. Then the next runner starts on a completely fresh track.
So the whole goal was to create a digital baton pass, a special command that you could put at the end of your first workflow that, once it's done, completely shuts itself down, clears out of memory, and then tells the next workflow, "Okay, you're up."
So how is this actually pulled off? Let's look at the specific tool that makes this relay race a reality.
And this is the piece of magic right here, a custom node from Creepybits called Chain Workflow. This thing is so clever. It doesn't just pass an image to the next step, it actually communicates directly with the Comfy UI server, the program running in the background, and tells it, "Hey, I'm done, wipe the slate clean, and now launch this next process from scratch."
There was one big catch, though. The server is picky.
It doesn't understand our normal, human-readable workflow files with all our little notes and colors. It only speaks a stripped-down, machine-only language called API JSON. Realizing that you had to speak the server's native language was the final piece of this puzzle.
And that makes the actual setup surprisingly simple. First, you get your second workflow ready and just export it in that special API JSON format. Second, you add the chain node to the very end of your first workflow. Third, you just tell that node where to find the JSON file you just made. And finally, you have both workflows use the same dead drop folder. One saves the image there, and the other one knows to pick it up from there. It's really that straightforward.
Now, it is so important to understand that this isn't just about taming one giant model. This technique unlocks a whole new universe of possibilities for what we can do with local AI.
Yeah, it was created to solve the Flux.2 problem, but the solution itself is universal. This relay race method can be used to chain any two workflows together, no matter how ridiculously demanding they are.
Seriously, think about what this means. You can now run these insane multi-stage pipelines on your consumer hardware. In initial image generation, which gets handed off to a refinement workflow, which then gets handed off to a video generation model. You can build these complex multi-stage upscaling processes that would have been completely impossible before. All of a sudden, the main limitation isn't your graphics card's memory anymore. It's just your imagination.
And that's the real takeaway here. This is about more than just a clever piece of code. It's about breaking down a fundamental barrier to creativity. So the only question left to ask is, now that the beast is chained and the VRAM wall has been knocked down, what will you create?